Long as a slamming screen door, sneaking out late, tapping on your window when you're on the phone and you talk real slow and it's late and your mama don't know. There's two kinds of places on the earth. There are continents, which stand high because they're made out of light materials like granite. And then there are the oceans, which sit low in basins because they're made out of rocks that are more dense, like basalt. Now, the continents contain a bunch of rocks that ranges in age enormously, from the oldest rocks in the Earth, which are almost 4,000 million years old, that's 4 billion, to younger rocks. But the ocean basins contain almost entirely young rocks. The old sitting high continents are spreading apart from each other because in the oceans, new rocks are made at mid-oceanic ridge spreading centers. Now, another thing you can see from the map is that the continents seem to be able to be joined together. And so Africa was once connected to North and South America, and Africa was also connected to India. So at about 200 million years ago, they began to break apart. We have been trying to understand the details of the breakup history of this part of the world, including these continental pieces. When did the ocean form, and how did the continents break apart? The island of Mauritius contains very young volcanic rocks. The oldest is about 9 million years old. And there are younger ones on Mauritius, but there's no rock on Mauritius that's older than about 9 million years. So in order to study the geological past, what becomes important to us is determining the ages of rocks. When did they form? The best way to do this is using radioactive isotope systems. The best isotopic system to do this involves the mineral zircon. And zircon is a special mineral because it likes to crystallize and incorporate uranium, which is radioactive, and it decays into lead. And we can measure these two isotopes very precisely. What we found in Mauritius by studying the volcanic rocks there were zircons that are extremely old. And this is a very surprising result because they really shouldn't be there. So there are a few grains within the trachyte that show ages of between 2,500 and 3,000 million years. So that's 2.5 to 3 billion years. Old materials, as old as 2.5 to 3 billion years, shouldn't occur in the oceans. When Africa and India began to spread apart, they leave pieces behind, one of which was later blanketed by volcanoes at about 6 to 7 million years ago, and it's invisible. So in that sense, it's a lost continent. It's not Atlantis, but there's a small fragment of continent that we can detect using the zircon ages that must lie under Mauritius. Long as a slamming screen door, sneaking out late, tapping on your window when you're on the phone and you talk real slow and it's late and your mama don't know.